Good afternoon, everyone, and welcome to the Hydrogen and Fuel Cells Europe here at the Hannover Messe 2023. We're here at the technical forum where we dive into all of the nitty-gritty details of the hydrogen technology. I invite you all to take a seat, have a drink. The hostesses are here to help you to anything from a cola to a coffee to a sparkling water. We have everything for you. Up next, we have a very interesting topic to talk about. We'll be talking about novel manufacturing solutions for solid oxide fuel cells, solid oxide electrolysis cells with AI-based inspection systems. I'm here with Haiku Tech Sales Manager, Mr. Hendrikus Oostra. Welcome. Please come to the stage.
Okay.
Welcome, Hendrikus.
Yeah, thank you.
Hi.
Okay, I'm Hendrikus Oostra from Haiku Tech, the Netherlands, the sales manager for machines for making SOFC, SOEC cells, mainly coating equipment and also screen printing equipment to manufacture the cells everyone needs finally in their applications. We are a Dutch-based and partly American-based company, and I'm representing here the European part. We have already about 20 years experience in SOFC manufacturing and ceramic cell manufacturing, and this is the basis that we developed also some equipment ourselves in order to inspect the quality of the films made in the machines which we are selling. And that's the accuracy vision inspection system which I would like to discuss here in my short presentation. My talk is the introduction which I already had. I will talk a little bit about the quality of the machine itself, quality detection of the machine itself, and where it is based on. Further, I will not really hold a demo because it seems that I need an internet connection for that, because that's on our server in the company. And we'll talk then about a few cases about training of data and the outcome of that for the near future. The accuracy system is based on a neural network system, but that comes later in the story actually. The first thing is of course relatively simple to say. That means it's a good light and there's a moving table, there is a camera and it's making pictures, as most of the vision systems actually do in the world. What we do in this is just need to check. Yes, 4. I will show you a short video about how such a machine actually looks like in, let's say, our manufacturing and demo room in the Netherlands. I will talk later a little bit about how such a machine also can function in the real world. You will see here a machine which we built. It has an inspection area. It has for sure a screen where you can monitor your data. It has an AI connection to the AI system, which is running on a server outside of the machine. You will see here a vacuum table where material moves into the machine, and actually in real time you will see about the speed of taking the pictures of such a surface of a cell. This is typically a fired cell, It's not necessarily fired cell, it can also be a green cell, so before the firing. In real time, you will see also on the monitor, you will see the defects which are seen in the tape. And these tapes will actually, these data will then be stored and analyzed, and finally you will get a picture of the analyzed data in the system. We built this system in order to have a very high scanning speed because we finally would like to build it also into automatic systems with a high throughput, because cell manufacturing will require that. Basically, the machines exist of the following components for the optical inspection. It has actually a very high resolution. We inspect surfaces with high speed on about 3.5 micron per pixel resolution, which is so far extremely high. And especially if you combine this with the power we have for calculating the defects, it's quite unique in the world so far. We can look at different kind of substrates, hard substrates, soft substrates, and finally, because it is a line scan camera system, we can also have moving substrates. This means a coating machine or a tape casting machine, or when stuff moves out of a screen printing machine, we can immediately look at the materials which are produced. The system itself does not require any adjustments like lenses or such kind of things. And yeah, for the experts, the platform itself is calculating with an extremely high speed, 90 teraflops. That's something like 20 up to 30 of the highest speed personal computers from calculation point of power. As I already told, because it's a line scan camera, it can also be running in an automatic system, and the system is built in such a way that is actually, yeah, more or less plug and play, I must say. We have the system itself is working in such a way that first we have an image without defects, and we have after that we have an image with defects, and this image with defects is then characterized by the system. And finally, you will see here on the square points, but yeah. You will have areas designated to specific defects seen by the system. I will talk about this this system a little bit later also. The anomalies means defects for us. So we do not say it is good or bad or whatever. It is just something that's different from the original surface, which is what we say defect-free. So the machine does not really need to have all kind of examples during the manufacturing to know what is a defect. It will just see it, and after that the machine will do something with this material, with this measurement. And that's what we call the anomaly classification. We have different kind of anomalies, and just to mention a few, there are defects like cracks, fibers, holes, pinholes, dark spots, and probably a few more, which we can finally teach to the machine. And this was our target, and that's also where the AI comes in finally. By teaching the machine defects in the sheets, we can finally say, okay, based on the photos you see on the left and here on the right, so what is the system seeing? Some pictures look a little bit blurry, but that's because they are more expanded, so they just fit in this square. But we see defects and we want to learn the machine finally what kind of defects do we see. Do we see a pinhole, do we see a hair, or do we see a crack, whatever. Because not all the defects finally will be something that's maybe classifying a cell as being off specification. And what our target is to have the highest, let's say, yield of a production line. And some defects, if it doesn't care for the final application, then we should also not care in the detection of the defects in the material. The system can, for sure, and you see that in the table, can see all kind of defects and mention this as an anomaly. It can see the size and the location of the bounding boxes, and we can classify this. And based on that, there is a possibility to say, okay, cell is good or bad. And this is the demo I wanted to show, but will not happen. So I have to move to the next sheet. We will have a score, a statistical score, the F score, which has to be 1 actually. Yeah, and I do not have so much time, I see. But if it's 1, it means it's a perfect score. It means it can separate the anomalies in a perfect way from each other. If it is a half, it means basically there is no statistic possible and it's just a random classification. So we teach the system on a few sheets, on a few materials. One of them is a solid oxide fuel cell plate. The other one was a high temperature co-fired ceramics tape. I can explain later if you are in our booth. But we saw by teaching the system only 20 plates and the other one 8 plates, we already have a very high score about the precision of classifying the defects seen in the plate. And this is actually quite unique at this moment, that by learning just 20 plates or 8 plates, we already have a very good discrimination between the failures in the system. This is still under development, so we want to increase this. Now up to 100% is maybe not possible, but we would like to increase this up to 78, 79% in order to have a very good classification of the materials. And if we can do this in line, then the user has an immediate feedback about how good is the cell, is it something that can be used in the rest of the product, or is it scrap? And the earlier you know this into your process, the better it is finally for your output of your factory. The last picture I would like to show is that the first products of customers are making are usually very bad. And so you see a lot of defects. The system has a possibility to set a threshold and of the detection, and this means first the big ones and later you go to the small ones. Actually, you start with a very high threshold to have the big ones eliminated, and then you go to the smaller ones to eliminate them. So the system can help you also in the production to improve your process and to improve the purity of your tape. So the conclusions, exactly in time, I would say. So you don't have to ask questions here. You can do it also in our booth. But actually, with 3.5 micron per pixel resolution, and with an extremely high speed, we can do nowadays inline inspection of cells, green cells, early in the process in order to achieve a very high yield. And I would like to stop with that. Thank you very much.
Thank you very much, Hendrikus, for your super interesting presentation. Unfortunately, like you mentioned, we don't have time to answer your questions here, but please visit Hendrikus at what booth?
F46.
F46. Thank you, Hendrikus.
Okay, thank you very much.